Example part B. 12y double prime minus 5y prime minus 3y equals 0. We obtain the auxiliary equation as 12 m squared minus 5 times m minus 3 equals 0, and factor completely to get 3m plus 1 multiplied by 4m minus 3 equals 0. Or you can use the quadratic formula to obtain m's. So with this factoring technique, so you get m equals negative 1 over 3 and m equals 3 over 4. So the y1 equals e to the negative 1 over 3 times x, y2 equals e to the power 3 over 4 times x. The general solution will be y equals c1 times y1 plus c2 times y2 as the two different roots. Example C. We have y double prime plus 10y prime plus 25y equals 0. The auxiliary equation is m to the second plus 10 times m plus 25 equals 0. Factor completely, we have the complete square, which is m plus 5 to the power second equals 0. So we have m1 equals m2 equals negative 5. So the solution y1 e to the power m1x, which is negative 5x. The y2, it has to be linearly independent to the y1. So gonna be multiplied by x, or x times the solution y1, which is y2 equals x times e to the negative 5x. Therefore, the general solution will be in the form of y equals c1 e to the negative 5x plus c2 times x times e to the negative 5x. Example in part B. We have equations y double prime minus 6y prime plus 10y equals 0. The auxiliary equation m squared minus 6 times m plus 10 equals 0. Solve for m. This one is not factorable, so you can do either completing square or do the quadratic formula. So let's do the quadratic formula. So m equals negative b plus minus square root of b squared minus 4 times a times c divided by 2 times a, which is 2. Now we get m equals 3 plus minus 1 I. We have two complex conjugate roots, which is 3 plus 1i and 3 minus 1i. And now you can see that alpha, or the real part, is 3. The beta, which is the imaginary part, is 1. The solution for this case is y equals e to the power real part, which is 3 times x, multiplied by c1 cosine times the beta, which is from the imaginary part, times x, plus c2 times sine of 1 times x as well. Or just e to the 3x multiplied by cosine x times c1 plus c2 sine of x. Next example, we have y triple prime Part E, we have y triple prime minus 3y double prime minus 4y equals 0. Set up the auxiliary equation. To get m to the third power minus 3 times m to the second minus 4 times m equals 0. Factor the common factor m out. We have m multiplied by m squared minus 3 times m minus 4 equals 0. And factor a little bit more to get m minus 4 times m plus 1 equals 0. We have three solution m's. So m equals 0, m equals 4, and m equals negative 1. Therefore, y1 equals e to the 0x, y2 equals e to the 4x, and y3 equals e to the negative 1 times x. And we write it as the linear combination of y1, y2, and y3. So the general solution y is c1. Actually, e to the 0x is just 1. So c1 times 1 plus c2 times e to the 4x plus c3 times e to the negative x as a general solution for this example. And part F, we have y triple prime minus 5 y double prime plus 3 times y prime plus 9y equals 0. The auxiliary equation is m to the third minus 5m squared plus 3m plus 9 equals 0. In this case, if we plot the graph, we can see one of the x-intercept is at x equals negative 1. So that means one of the factor is m plus 1. And to find the rest of them, you can either use the long division or the synthetic division. So if we use the synthetic division, negative 1, and then list the coefficient of the equation of the power 3 as the coefficient of m to the third, negative 5 coefficient of m to the second, 3 is the coefficient of m to the first, and 9 is the last number. With the synthetic division, take 1 down and then multiply negative 1 to 1 to get negative 1. Add it with negative 5 to get negative 6. Negative 1 times negative 6, we get positive 6. Add together with the 3, we get 9. Next, negative 1 times 9 to get negative 9. Add together with the 9, we get 0. When we get 0, that means the rest of the factor here will give you the next coefficient, the coefficient of the rest of the terms. So then m to the third minus 5m squared plus 3m plus 9 can be factored as m plus 1 from the known x-intercept multiplied by 1 times x m squared minus 6 times m plus 9 equals 0. And then we can see we can factor more of m squared minus 6m plus 9, which is m minus 3 times m minus 3 equals 0. For this case, we have m equals negative 1 equals 3 and equals 3. Now we have repeated roots. So y1 equals e to the negative 1 times x. y2 equals e to the 3x. Since y3 is repeated with y2, so y3 will be x multiplied by e to the power 3x, put together as the linear combination to form the general solution. Will be in the form of y equals c1 e to the negative x plus c2 e to the 3x plus c3 x times e to the 3x